In this video, we are going to talk about the dot product, scalar product of vectors. So, what is meant by the scalar product of vectors? Well, the dot product tells us that if you have a vector A and if you have a vector B and if you use the dot product operation on them, the output will be equals to A1 B1 plus A2 B2 plus A3 B3, where A vector is equals to A1, A2, A3, and vector B is equals to B1, B2, B3. And this is what we call the dot product or scalar product. Okay. And this also has the dot product also has another perspective which says A vector A dot vector B is equals to modulus of vector A into modulus of vector B into the angle between these two vectors, cos theta. So how can we represent this? Well, let's say there is a vector A and let's say there is this vector B. Okay, so this is vector A and this is vector B. This is the angle between them. Not this. This is not the angle that we are talking here. The angle that we are talking here is the angle here. It is not mandatory to be, it's not a mandatory that theta has to be always acute. No, it can also be obtuse. It depends on the vectors. Okay, so I'll give you an example. Well, in this case, if you have the A like this and B like this, well, then the angle will be obtuse angle. It doesn't have to be an acute angle. Before I move further, we should talk about some properties of scalar product. So we are going to look at some properties of dot product. So if we have vector A dot B, that is also equals to B dot A. For example, if you have a vector AB and you are applying the dot product operation with CA, well, that will be equals to CA dot product AB. The order doesn't matter. And then we also have another property. Let's say we have A dot B dot C. Well, this will be equals to A dot B dot C. And that will also be equals to A dot C dot B. This is another property of dot product. And then we also have another property for dot product, which is A into vector B plus C is equals to A dot B plus A dot C. It's like multiplying normal variables. Okay, the distributive law. Okay, so these are some properties of dot product. Now I'm going to teach you some of the iconic things you can see in dot products based on the angle between the vectors. Okay. So let's say there are vectors like let's say we have vectors A and B which are parallel to each other, which means the vectors should look like this. We have vector A and we have vector B. These two are parallel to each other. Okay. So what is the angle between them? Well, the angle between them in this case is equals to 0. Theta is equals to 0. If I bring this closer and closer, and if I connect the origin points together, we can see the angle between them is equals to 0. We can clearly see that. So this can be written as A dot B is equals to magnitude of vector A into magnitude of vector B into cos theta. And cos theta in this case is equals theta. Since theta is equals to 0 in this case, we can confidently say this is equals to magnitude of A into magnitude of B. This is something you can observe in dot product. Now let's go to type 2. What if two vectors are perpendicular to each other? What if two vectors are perpendicular to each other? Well, the representation must look something like this. We have vector A and then we have vector B, and they are perpendicular to each other. So here we can clearly see that the angle between them is equals to pi by 2, and cos pi by 2 is equals to 0. So if I apply the dot product here, A dot B is equals to magnitude of A into magnitude of B into cos pi by 2. And cos pi by 2 is equals to 0. Okay, cos pi by 2 is equals to 0. So I can clearly say A into B, A dot B is equals to 0. And what about another type? Let's say type 3. Well, in this case, let's look at what about the same vector is dot produced. Okay, if I apply the dot product on the same vector, such as A dot A, well, here I can apply the type 1 directly. Okay, I can apply the type 1 directly. Okay, since A dot A, we know A is parallel to A. That's the idea behind this. And the representation somewhat looks like this. So I have a A, and on that A, I have another A. On that A, I have another A. So the angle between them will be equals to 0. Theta will be equals to 0. So I can say A into A is equals to modulus of A into modulus of A, which is equals to modulus of A whole thing squared. Let's talk about type 4 now. What if I use the dot product operation on A and negative A? Well, in that case, okay, even though they are parallel to each other, but they are not in the same direction, they are in the opposite direction. So it should look something like this. If I have A here, negative A should look like this. Okay, so if this is A and this will be negative A. Okay, now how can I find the angle between them? Well, I can bring it here. So if I bring it here, I can see they create some sort of a straight line, which means the angle between them is equals to pi. Okay, so if I apply that, so in this case, theta is equals to pi. So if I apply that, I will get A dot minus A is equals to A. Modulus of minus A is also equals to A. We learned in the finding the magnitude lesson. So A into A cos pi. And we know cos pi is equals to negative 1. So A dot negative A is equals to minus modulus of A whole thing square. These are some observations that we can see when we are applying the dot product to some vectors. Okay, this is how we can see the some of the observations in dot. So to summarize, we have 4 observations. Okay, so if A is parallel to B, A dot B will be equals to absolute value of A into absolute value of B. And if A is perpendicular to B, A dot B will be equals to 0. And if A is dot produced with A, okay, if I dot produce A with A, then that will be equals to modulus of A whole thing square. And A dot negative A will give me minus modulus of A whole thing square. So this is it for this video. We will look at some practice question in the next video. Thanks for watching the 8th video in our vector series. If you found this explanation of the dot product and its properties helpful, don't forget to like, share and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos. Check out the full playlist to master vectors and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.